Let's kick off the learning series where I will discuss the previous year question of UPSC CSE mains paper of electrical engineering optional, and I'll leave you with the points where you can be extra careful while dealing with the question in more interesting and easy way as we go along. It's the sixth part of the series. This question was asked in 2010. Let's read the question. A 50 ohm lossless line is terminated with a dipole of input impedance 73 plus J42 ohms. Find the reflection coefficient VSWR and estimate the reflected and transmitted power. If the input power of the line is 10 watt, also calculate the maximum and minimum impedance on the line and suggest the two methods of the matching such a load to the line appropriately. Solution. What are the things we have? We have Z0, which is characteristic impedance 50 ohms. We have with a dipole input impedance, so Zin we also have, that is 73 J42. Find the reflection coefficient. Okay, so what are the things we need to find? Reflection coefficient. Okay, we need to find voltage standing wave ratio and estimate the reflected and transmitted power. We need find reflected power and transmitted power. This also we need to calculate. We have for V Pin is equal to 10 watt. So here it is talking about input impedance of the dipole antenna. So what happens? I can brief you. Let's assume this is a transmission line, right? If this is a transmission line, this is Zn, right? From our transmission line, this is let's suppose there is an antenna connected to this, right? Assume this is an antenna. We can call this as antenna, right? Now it is saying that the input impedance of dipole antenna is 7342J, right? If this is the input impedance of the dipole antenna, that means that for this transmission line, this will be the load impedance. So this becomes load impedance of this transmission line, right? Now we will try to solve this question. What we need to calculate? Reflection coefficient. Reflection coefficient, what is the formula? That is ZL minus Z0 upon ZL plus Z0. What is the value of ZL? Yeah, 73 plus J42. What is Z0? 50 upon ZL 73 plus. What we have done, we have just substituted this particular value. This will be 23 J42. This will be 123 plus J42. The idea is now we will try to solve this particular equation in the form of x plus iy, so that we can convert this into the polar form, which is x square plus y square under root tan inverse y upon x, right? This we need to calculate this value. What we will do, there is other ways also, like you can what you can do is you can calculate magnitude of the numerator, magnitude of the denominator along with the angles. This is coming 47.885. upon 129.97. The value of this is coming as 61.29 upon this will be 18.85. The value of this is coming as 0.3684 angle. This will be if you will minus, this will be 42.44 roughly. So what we have calculated, we have calculated reflection coefficient at load. This is the first answer that we have got. This is the first answer that we have got, which we were looking for. From here we can say that what is the magnitude of reflection coefficient? That is 0.368. Now for the second part of the question, what we need to calculate? Voltage standing wave ratio, which is nothing but 1 plus modulus of reflection coefficient upon 1 minus modulus of reflection coefficient. Here this is 0.1, this is 1 plus 0.684. We will just basically try to substitute the value. This is 1 minus 0.3684. This will be 1.3684 upon 0.6315, almost roughly, and the value of this will be 0.166. Hence VSWR can be written as, this is the second answer we got. Now we need to find the reflected and transmitted power. See, as we know that, now we need to find reflected power, right? Reflected power, that is reflected power, that is nothing but incident power into reflection coefficient whole square. This is the formula. Reflected for, this is the formula. Now we already know that what is the value of incident power, that is given in the question, that is 10 watt into, we have just calculated the value of the reflection coefficient. We will what is the value? 0.3684 whole square. PR can be written as, after calculating, this will be 1.357 watt. Right, we got the another answer. Now we need to calculate the transmitted power. See, we know that incident, we need to calculate now transmitted power, PT we need to calculate, right? We know that whatever the incident power is nothing but the transmitted power plus the reflected power, right? Now PT can be written as PR PI minus PR, right? Whatever the incident power is equal to transmitted power plus reflected power. Now PT can also be written as PI minus PR. What is PI? Incident power, that we know 10. We have just calculated reflected power, that is 1.357. Then transmitted power can be written as 8.643 watt, right? We got the another answer. Now there were two things we need to find. One was now we need to calculate maximum, Zmax and Zmin, right? See, the maximum impedance can be written as, what is the formula? What is the formula? That is nothing but Z naught into VSWR. What is Z naught? That is given in the question, that is 50. Voltage standing wave ratio we have calculated, that is 2.166. What is the value? That is 0.083 ohm. Right. This is Zmax we got. This is Zmax we got. Then for Zmin, minimum impedance, that is nothing but Z naught upon VSWR, that is 50 upon, what is the value of 2.166? That will be 23.084. So Zmax is 0.8 ohms and Zmin equal to 23.084. This is the answer. Hey, great to see you until this point. Please drop your doubt in the comment section if you have any. Please subscribe to the channel Sinc UPSC for such videos. There are plenty of videos coming up for other subjects too. Happy learning.